Welcome to the session. Greeting of the day. In today's class, we are going to talk about the types of activating systems which are going to help in the Mechatronics total sketch, total systems. So here this activating system is going to function from there through the CPUs, through the microprocessors, through the microcontroller. We are functioning. We are feeding the programs. But at the output end, the actuating systems is the output device which are going to process. So that we are going to see in the upcoming classes. This actuating systems, the basic functions to provide automatic and precious motion control to its elements, such as we have to operate the function, maybe moving a table. I'm just an example I'm telling, moving the table or spindles or CNC operations, any robotic functions, or switching on the motors or running or switching off pneumatic controls, hydraulic controls, any some actuating systems to be done. So for that we are going to see these various functions. A derived system, I'm naming this as actuating, or otherwise this is a deriving system. It's going to drive system of a typical mechatronics based systems like CNC operation. For example, I have taken that. It consists of driving motors and the ball lead screws. Control unit, that means the microprocessors. Control unit actuates the actuating system of driver motors, and therefore the motor will going to rotate the ball lead screws, and therefore to rotate, to move the position of the machine table. For example, just I have given one example here. We are going to move the CNC table. How we are going to move? By operating the motors, the lead screw rotated, through that the table may move ahead. So such examples can be operated by actuating systems. So I am dividing this actuating systems into three categories of drives used in automated systems. Can be maybe electrical devices, number one, maybe the hydraulic devices, maybe this pneumatic devices. This all are going to be the act as a actuating deriving systems. Deriving, or otherwise I am calling it as actuating. Actuating systems. So this one by one we have to see what are the electrical parts are there, what are the hydraulic parts are there to actuate, what are the pneumatic parts are there to actuate in the upcoming classes. So number one, I am taking first one, I am considering the electrical for our upcoming. So electrical drives. So these are the direct current or alternating current. Anyhow we are applying the power sources to the motor. This is the actuating system. A stepper motor we are actuating. Servo motors are the actuating systems. They are small in size, are easy to control. Pneumatic drives. Next, out of these three, I have given an electrical supply, maybe a DC or AC current, so stepper motor or DC motors or servo motors, which are easy to control. And then I am coming to the next one of pneumatic drives. Use air or gas. Pneumatic, the name itself says air or gas to working medium. Air is abundant and fireproof. Therefore, equipments are simple in constructions and also cheaper. We are not using any fluid systems. We are not using any power sources such as powers, electrical drives. Nothing we are using. We are just using air, compressed air to operate a pneumatic system. We know this. However, this drives generate low power. As compared to the other processor, this pneumatic power sources actuates low powers, have less positioning, accuracy also, and it creates more noise. When the air is released from the compressed state, it releases a noise. So even though we can able to, while during the work area, it disturbs. So we have to take care of that. So the next, third one, hydraulic system. Use of this hydraulic fluid petroleum based oils. This drives have a large power to size ratio. Stepless motion with good accuracy we are getting. There in the pneumatic we have not get this accuracy, but in the hydraulic system we are getting good accuracy systems. Difficult to maintain and are bulky also, because air we are getting from everywhere, but this hydraulic system is not like that. We should have maintained some tankers and fluid systems and then the supply, so that is somehow it is bulky as compared. Structural elements need special treatment to protect them against the corrosion. Even though the fluid, the container, I am keeping the fluid here and I am using this for the pneumatic action to push the piston here. So such cases I am using. When these oil items are comes here through the pipe, it will going to pressurize and this piston action to be taken place. It's going to push there. That is what the actuating system is going to happen. But the container, these zones are subjected to corrosion. This due to fluid interact with the tank panels or whatever it is, the storage devices. That is going to be contaminated or getting corrosion as it is 100% 24/7 contact with the tank or contact with the fluid. Therefore, it may be corroded. So these things and all coating to be given to the storage tanks. Otherwise, frequent services are needed. Such difficulties are there to maintain. Number 1. The drives used in the typical automatic systems of, like example, I have taken the CNC machine tool. In this machine tool setup, a computer numerical control CNC of turning center, a spindle drives. First, a spindle drives provide angular motion to the workpiece. So this is one of the actuating system. Actuating is done. It is going to the angular motion we are doing through the spindle motor drives. So here this motor drive we have used. What we have earlier to this connection, how we are connecting? We are controlled using maybe a CPU which contains microprocessors here. Microprocessor, a control unit, that is something what a control unit. Control unit. So this control unit we have seen the same setup in the closed loop system. See, here we have a small connection, maybe a sensor, whatever it is, a feedback command system we are connecting to the controller, through which how much the length of the table has been moved, how much it has been moved, so that the feedback system we are taking, here the feedback system will be there. I think we remember feedback. Feedback system is there, therefore we have taken the feedback to the control unit, through that which contains whether it should be moved in the correct position or any changes are needed. In such a way we can give again the input connections are given. Therefore, it has been, again it is rotated or reducing the speed or increasing the speed to the spindle actions. Therefore, it can be able to move or stop the work table in a specific point. So, that is spindle drives. So, that is how used to drive the slide or the table of contents. So, this is a simple methodology you can able to understand. So, this advantage of electrical drives and what are the limitations? One by one we have to see. See, in this electrical drives, extensive range of speeds, large motor systems, high speed rotations, torque we will achieve quickly. So that speeds and powers and they have given, it is given torque. We can able to achieve it at a higher energy rates. No requirement of refuels or fillings or any fuel systems or power source needed. It is environmental friendly also, and even if it is increased speed, maybe the stable speed we can able to, as a constant power apply, constant rotating speed is there. But there is a problem when there is a load applied on this speed, like a fans or when the load applied, this varies, like opening doors and AC control system, this varies. That has to be monitored by the closed loop system. So this is one part. So what are the limitations? Access to the power. So here's the fuel is not there, but accessing of power is difficult. Initial cost also very difficult, and may have noise pollutions also possible due to motor sound rotating. The winding sounds will be there to cause the noise pollution. These are all to be taken into the note. The applications of this electrical drive system. Out of 3, now we have started with electrical drives, then you have to go for the pneumatic, then you have to go for the hydraulic, then this module will be completed. So transportations of the materials, we are using the electrical trains. You see, for the heavy trains we can be operated by electrical motors or electrical connections. Electrical trains or buses or trolleys, solar powered vehicles inbuilt in the batteries. The Tesla cars they have built now. Otherwise the solar powered cars, some electrical cars we can take. Domestic as well as in the industrial applications also. It means home appliances and also the industrial appliances we are using, where the motors or transportation systems in factories or textile mills or the pump industries, everywhere we are using this actuating systems. Now we come into the division of this electrical drives. So electrical drives, the electronic drives are mostly used in positioning and the speed control system, where it is to be and how fast it is to be. So those two concerns are controlling by this electronic drives. The basic classifications I am doing, these electronic motors are classified into 2 categories of AC motors, alternating current motors, and obviously this direct current motors I am dividing. Further, this 2 I am classifying into another 2 categories of synchronous motors and induction motors. This is apart on the AC. Apart on the DC motors, we have a brushed motors and a brushless motor systems are there. So this basic principle of functioning of motors we need to know, which is related to the mechatronic system for spindle actions or rotating or torque generations, principles for the mechatronics. So therefore we are here to understand the functioning of the motors. Now I have taken first on this list, I have taken this DC motor principle I have done. A DC motor is a device that converts a direct current electrical energy. You are giving electrical power source energy there into rotation, into the rotation of the element. It means the power is converted into mechanical energy of a rotation energy of mechanical energy. These motors can be further classified into 2 categories. This is what we have seen there. A brushless motor and the brushed motor and the brushless motors we can able to take. So that is what the same. Number 1 as a brushless DC motor. Number 2 as a brushless DC motor we have taken. So on this we have to one by one. Number 1 of a brushed type DC motor in the actuating system in the electrical. So from the actuating system we have divided these 3 categories. One is electrical, and then one is pneumatic, and one is hydraulic. From this we have taken this electrical into AC and DC, and this DC we have divided into brush and brushless. Now we are seeing this brushed DC motor, both we have to see. So this typical brushed motor consists of the components what we have: an armature coil and a splitting ring divided into 2 parts. Splitting rings divided into 2 parts, a pair of brushes, and the horseshoes of electromagnets. These are available there. This is the armature we have given, which is going to rotate in between the poles. This we have already seen in the basic electrical subjects. So the same functioning of motor we should know for the functioning of the all electronic or mechatronic systems. So therefore the 2 field poles of namely a north pole and the south poles are there. So north pole and south pole, in between this north pole south pole magnets, we are going to keep the armatures which is going to rotate by this action of magnetic field creations. Due to this magnetic field, obviously this armature will rotate, this armature will rotate, the brushes will be attracted, through which the magnetic field generated causes the supply of power source of positive to negative, therefore you can able to reduce the power. So that also one of the, through this how many fast it is rotating, we can able to generate the arc torque. So brush type DC motors, here we have a north pole and south pole as mentioned earlier. Further, the magnetic lines of force extended across the opening between the poles from the north to south. So we have the opening between the north and the south poles, we have kept an armature. The coil is wounded around. The coil is wounded around the soft iron core and is placed in between the magnetic poles. The coil is arranged this coil. So this coil we have arranged, and then it is placed in between, the north and the south pole categories. Now what happens? This electromagnetic receives electricity from the outside power sources. This coil ends are connected to the split rings. So this coil is again connected to the split rings forwards, and this here we have the brushes. So this is one brush and this is one more brush through which the power source are connected to the both end of positive and the negative. What happens then? The carbon brushes are in contact with the split rings. Yes. So this having two contacts where this is going to rotate now due to north pole south pole actions when the power source is received. These brushes are connected to the DC sources. So positive and negative connected. And then here the split rings are rotated with the coil while the brushes remains stationary. Therefore what happens? Therefore the direct current in the set windings creates a magnetic field. Now the magnetic field is created in the set windings. So here the magnetic field is created. This field produces a force which in turn turns the armature. When the power supply is given here, the armature is getting rotated, and this force is called as a torque. I am calling this as a torque. This rotating is a torque. This torque while causes the armature to turn until the magnetic field is aligned with the exact field, whether in which direction of magnetic field is created, whether in the north pole direction or south pole direction, until it is keep on rotating. So once alignment in the direction of the current, the windings on the armature is reversed. When it is connected to same direction, it is started to reverse like this. So thereby, the reversing the polarity, again we are connecting this positive and negative in the other directions, we are changing. When it is changed, the rotor electromagnetic field, the torque is once again extracted on the rotor, and it's continuous to rotate in the opposite direction. So, but it keep on rotating with respect to this to north pole and south pole. What happens therefore? Therefore, we can able to generate the arc, or we can able to rotate the spindle in the one direction. The north pole and the south poles are changing their power sources to keep on rotating. When the pole is reversed, again this circulation continues until it reaches to the same magnetic field. But so again it rotates. Pole repeat. Again this comes to the original position. When the pole is rotated, again it comes there, again it comes there, again it comes there. Therefore it keep on rotating. So this principle is used to generate the speed on the shaft. In such a way we can able to get it in the spindle speed of a torque, rotation or movement or anything. When whatever connected to the shaft we are getting as a output. It means nothing but actuating systems. The advantage of this brushed DC motors. What we have then? See, the design of the brushed DC motor is quite very simple. Yes, we have a system of north pole and south pole, and we have armature and splitting rings, and the simple brushes are there. And when the supply is given, armature is going to rotate, and therefore we are connected to the shaft, which is taken out as actuating system for a torque outputs. Very simple constructions. Controlling the speed of a brushed DC motor is easy, very cost effective. cost effective. Okay. These are the various advantages of this DC motor, brushed DC motor. What is disadvantages then we have in this? We have high maintenance cost is very importantly very high. We have to keep on this brushes will be damaged. So this is to be at every time we have to replace. Therefore, it causes the change in need. Performance decreases with the dust particles. So when there is a dust particles are there in between this, maybe the armatures and the north pole and south pole, the attractions are reduced. This reduction in this magnetic field over the armature simultaneously reduces the speed also. Speed of rotation, torque is reduced, getting speed reduction and torque reductions are happen. Therefore, this maintenance of north poles or any poles with respect to any dust particles to be taken care. So that is to be cleaned subsequently at every time before switching on, switching off. Those that cleanliness to be ensured. Less reliable the control of lower speeds. Whenever it is started, minimum speed of minimum 2 degree angle to rotate or 5 degree angle to rotate not possible. I have to move from here to these locations. So this is simple. Or maybe we can tell 5 degrees. A moment of rotation to be completed right is one revolutions. On that minimum revolution, minimum movement of servo motor we can keep 1 degrees. But now by this DC motors, minimum rotation may be 180 degrees. So such is not possible for the lower minimum angles or minimum slow speed are not possible. Immediately armature polarity we are getting, and then therefore immediately starting to rotate. Maybe the medium speed will rotate, not the minimum speed we are not getting in such cases. So what we should do, we should go for the other servo motors mechanisms. We should do where minimum angle we can able to achieve. The brushed wears of this usage. So these brushes will take on wear possibilities. So this wear possibility decreases the effectiveness of the power sources. Effectiveness of the power source. So this is all to be done carefully, which is to be maintained. So these are the cases we have to. So other than this, we have the other types of this we have done now. The brushed motors, this we have done. And one more things we have to do is this brushless motors. What is the function of this brushless motor? We have without these concerns of brush. Without this taking of the brush, we have removing the brush and directly connecting those things to the same setup of north pole and south poles. Brushless DC motors. This also contains as usual the north poles and south poles here, but instead of using those brushes, I am converting without brushes forward. The brushless DC motor has a rotor with the permanent magnets and a stator with the windings. The rotor which is going to rotate at center. See, this is the rotors. This one, which is denoted to the inside view. The north pole and south poles are there, and the stator is nothing but we are going to going to be at a static view. Here we have the stator at the outside, which contains each and every one, the red color, green color, and yellow color. This all belongs to the windings. Which way we are going to release. So these windings are connected to the electrical circuits. So you see, the brushes are eliminated. The brushes are eliminated and windings are connected to the control electronics. So these windings which are wounded over the rotors of A1, A2, B1, B2 and C1 and C2, we have 3 into 3. So these are connected to the electronics circuit. The control electronics energize the stator subsequently. So through the electronic system, through the power sources, we are going to energize this stator. So through stator I am supplying, let us consider I want to energize this direction. I want to move, I want to rotate an angle of likewise. From here to here I want to move. What I am doing, I am energizing here. This conditions I am energizing. What happens? The north poles are attracted toward this position and therefore we can able to move about the 90 degree. So this and the south pole will be attracted here simultaneously and here also we will get one more 90. So continuously as per the energizing, maybe the B1 or B2 the direction, or maybe the C1 or C2 the directions, or whenever this north pole and south poles in the B1 or whenever south poles in the B2, when we are energizing this A1 it comes rotating here. So as per the sequential of energizing formula, we will get the rotation of the north pole and south pole, and there we will get the torque and the shaft which were connected, there we will get the rotations. So such how we can able to easily operate this motor systems. The current supplied to the stator is based on the positions of the rotor where we need. Position of the rotor in case the position of the rotor is here, let us consider it is in the position is here. Then I want to energize this C1 and C2 in such a way this comes here. And later I want to energize A2 and A1 in such a way it comes here. Later I want to energize the B2 and B1 in such a way it comes here. So we want to sequentially energize B1, C1, A2. Similarly this side B2, C2, A1. So we have to sequential operations of energizing method is needed to rotate this rotor in such a way as the rotor is rotated we can connect it to the other end to the rotations. It is switched in sequence. It is switched in sequence using the transistor at the other end. The position of the rotor is sensed. But we are using here the Hall effect sensors to identify where the position is. The position sensor Hall effect. And thus continuous rotation is, and therefore energizing subsequently the next one A2, B2, C2, A1. Likewise continuous rotation can be obtained or possible. So what are the advantages now here? We can able to tell the advantage of brushless motor, the more precise operations we can do. Of what the percentages of need. When we are increasing the stator, I am introducing one more stator here. Therefore, this 90 degree formula can be reduced further. Very less than small degree, micro degrees can be obtained with count of stators. So more precise operations, computer controls, more efficiently operated, and no sparkings, absence of brushes we are not used. Less electrical noises also is getting reduced. No brushes, no wear out. As the brushes are not there, the wearing formula wearing also is not there. Just windings, supply, and then it is rotating. So electromagnetics are situated easy to cool. So what are some disadvantages? As usual, the initial cost is high, and we have some complex design formulas of stators and rotors which is to be there. But there we have only north pole and south pole, and the center we have the windings rotated, but the controlling of precious movement is not there in the brushed DC motors. But here we have brushless DC motors where the precise controls are possible. In today's class, we have seen about the electronic or driving system. I am naming this as an actuating system. In this actuating system, I have divided into such three categories of electrical drives, electronic drives, and then here we have these two categories of AC and the DC. This what we have seen in AC and DC. Here we have seen about this brushed and brushless. In AC we have seen about AC. In the by the graph we have seen about synchronized and induction motors. So we have seen about this synchronized and induction motors. This is apart. Then the second one we have to see about the pneumatic systems, and last we have to see about the hydraulic systems also. So by this we have complete one module of named as a driving actuating systems. The remaining part of the subjects we'll see you in the next session. Thank you.